Friends, welcome to my channel. My name is Obhijit Dhar and today I am going to discuss about a very important topic called time complexity. Now what is time complexity? Time complexity of an algorithm signifies the total amount required by the program to run till its completion. Now if I take an example, here is small algorithms are there which actually return two values, sum of two values. Okay. So whenever I write this algorithm or if I want to execute this particular program, it will take some time. So this time is measured through time complexity. Now for different program, time complexities are different. Even one program can be written in different way also. For example, if I want to write a factorial program, we can write factorial program in iterative way, that means using for loop or while loop, or we can write factorial program using recursive way. In for both cases, again the time complexities are different. Now take an example. Suppose one array is there. In an array, suppose like 6 or 8 numbers are there. Now between this number, if I want to find this 67, so we know that we can search the number from an array in two ways. One is called the linear search, another is called a binary search. So if I search this number using linear way, so its time complexity is what? That is O(n). But in case of binary search, its time complexity is O log n. So how I find this O(n) and O log n? This is our main concern. We will discuss these things little bit later, right? So we know that the efficiency of binary search is more than the linear search. And we know that O log n is less than On. So how can I tell that O log n is less than n? For that we have to depend on some classes of function. Look at this. These are the classes of function. First is O1. O1 means what? Remember, this one is order of 1. It's not a big O notation right now. Okay. We will discuss about big O notation like big omega, big theta in my next tutorial. Now this one is O1. It's a constant function. It's called constant function. Not only that, instead of O1, if it is O like 20 or O100, anything, all are like constant function. Next function is known as the O log n base 2. This one is known as the logarithmic function. Next is called the On, that is known as the linear function. Okay. Next one is what? It's called the On square, that is actually known as the quadratic function. On cube, it is known as the cubic function. And O 2 to the power n, this is known as exponential function. Now, whenever we try for different algorithm, you will find in some algorithm it's like On, some algorithm time complexities of some algorithm is On square, time complexities of some algorithm is On cube, etc. Okay. Now, if these are the classes of function and if I want to write this function in increasing way, or like if I want to write these classes of function in their increasing growth of their weightage or priority, we can write in this way, that is 1 less than log n, less than root n, less than n log n, less than n square, less than n cube, in this way. So here it is clear that log n is less than n. Okay? And that's why we can say that binary search is more efficient than linear search. That means it will take less time compared to linear search. This is a simple graph. and this is represented by this graph. That means first look at this, that is O log n, then n log n, O n to the power c, O c to the power n factorial, and this way. Now coming to some example, here we can explain the time complexities, how to find out the time complexity is the most important part. Here I have already written some algo so that it will not take extra time, because if I am going to type all this thing, the video may longer unnecessarily. But our main motto is what? We have to know what is time complexity and how to find out the time complexity. Look at this. One function is there called swap a comma b. Now it's a swap function, and if I want to swap to number, we know the program. We just take a temporary variable t equal to a equal to b, and finally we store the value of b into t. So if I execute this program, it will take 1 unit of time, the first line. The second statement take 1 unit of time, and third statement again take 1 unit of time. So it will take how much time? That is 3 unit of time. So we can say this one is what? This one is a time complexity. If I want to say the time complexity is O1. It's a constant value. So whenever some constant values are there, look at this. Whenever some constant values are there, it may be O1, O20, O3, O5, anything, we can represent it as O1. That is order of 1. Now go for the second example. Add a comma b. Now this one is temp equal to a plus b. Simple, I want to add two number a plus b. So here it will take how much time? Again it will take 1 unit of time. Right? So what is the time complexity? Time complexity is again O1. Third example. Look at this. Here one loop is there. It's I equal to 1, I less than equal to n, I plus plus, and sum equal to sum plus I, and simple I want to print the value of sum. Now if I find out the time complexity of this loop is executed n time, or we can say n plus 1 time. Why it's n plus 1 time? Because suppose if the value of n equal to 5, so it is exited from the loop when the value of I is 6. That means it is go for one more extra time. That means we can say that n plus 1 time. But the thing is that as it's a constant value, so we don't consider this one. So suppose this one is executed n time, and as this statement is also executed n time, so how much time it will take? Total 2n time. So what is the time complexity? The time complexity is O(n), because we take always the degree of polynomial. This one is O(n), linear function. So whatever the value is, that means if it is like 20n, the time complexity is what? If I write 20n, then time complexity is O(n). If I write n by 2, if I write suppose n by 2, then again the time complexity is n. Go for next example, example number 4. Here, the same program, like in different way, one factorial numbers is there. So just loop is in backward. That means I equal to n, I greater than 0, I minus minus. So f equal to f into I. Again, this loop is executed how many time? This one is executed n time, or n plus 1 time. Now this one is executed n time. So what is the time complexity? Again n. That is order of n. Clear? Next, example number 5. Look at this example. Suppose n equal to what? That is 10. Now, look at this loop. I equal to 1, I less than equal to n, I equal to I plus 2. That means it is incremented by 2 time. It's not 1 time. So, how much time it will take? Suppose if the number is like n equal to 10, then how much time actually it will take? It will, like, first the value is what? That is 1. Then next value is what? That is 3. Next value is 5, 7, 9. In this way it will execute it. So next value is 11. So it is exited from the loop. So how much time it will execute it? 5 times. So what is the value of n? That is 10, and it will execute it 5 times. So we can say this one is n by 2. Okay, and this one is executed how many times? That means n times this statement. So how much time it will take? That is n plus n divided by 2. That is 3n by 2. And what is the degree of this polynomial? That is n to the power 1, that is n, and time complexity is again order of n. So from this example, it is clear that if there is only one loop, the complexity or time complexity is order of n. Now look at this particular loop. Question number 6. Nested loops are there. So suppose n equal to 3. For I equal to 1, I less than equal to n I plus plus, and j equal to 1, j less than equal to n j plus plus. Now if I want to execute this loop, look at this. When the value of I equal to 1, j executed how many times? That is 3 times, right? Because I equal to 1, j equal to 1 to 3, value of n is what? That is 3. So when the value of I is 1, j executed 3 times. When the value of I is 2, again j is executed 3 times. When the value of I is 3, again j is executed 3 times. So first this one outer loop executed how many time? That is n time. The inner loop is executed how many time? That is n into n time. Look at this, because the value executed j is executed 3 into 3 into 3 9 times. So when the value of n is 3, it is executed 9 times. So we can say n into n, and this statement is how much time it will execute it, that is n time. So if I add all this number like n plus n square plus n plus n square plus n, so it will take n square plus 2n time. So what is the time complexity of this? The degree of polynomial. What is the degree of polynomial? That is n square. This one, the result is what? That is n square. It's a The time complexity is O, the order of n square. Go for the next example. Look at this. Here, the loops are little bit different. Now for I equal to 1, I less than equal to n I plus plus. For j equal to 1, j less than equal to I. Now j is depends on I. In my previous example, j is not depends on I. Here, j is depends on I. So as j is depends on I, the j executed or executions of j is depends on I. Now look at this. When the value of I is 1, j executed 1 time because j less than equal to I. When the value of I is 2, j executed 2 time. When the value of I is 3, j executed 3 time. And when the value of I is n, j executed 1 time. So if I find the value of j, it is incremented by, look at this, 1, 2, 3, dot, 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 up to n. So number of time we can say in this way: 1 plus 2 plus 3 plus 4 plus dot, 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 n. It's an AP series. And what is the formula of this AP series? N into n plus 1 divided by 2. That means n square plus 1. So as it is n square plus 1, we can say that this one is again O n square. It's a time complexity. Clear? So from this we can again say that if two loops are there, like nested loops are there, then the complexity is O n squared. If three loops are there, for example, so n, then n squared, then n cube. So how much time it will take? For time complexity is what? That is O n cube. Okay, look at this example. Now it's something different. Look at this: I equal to 0, I equal to 1, and then I less than n, I equal to I into 2, and then p equal to p plus I. Look at this, it is multiplied by 2 times. So if I follow I, what is the value of I? First time the value of I is 1. The first time value of I is 1. Then what is the value of I? It is incremented by 2 times. So 1 into 2, that is 2. And now the value of I is 2. Again it is incremented by 2 times. That is 2 into 2. That is 4. Instead of 4, you just write 2 square. You can write 4 or you can write 2 square. Now look at this. 2 square into 3. That is what? That is 8. Okay. Instead of 8, we can also write 2 to the power 3. Now 2 to the power 3 into again 2, that is like 16. So that is 2 to the power 4. If I increment this value, the value is incremented how many times? That is, it is up to 2 to the power k time. Okay. So this one, look at this. As we don't know how much time it will execute it, we assume that this will execute it up to k time. So this one is 2 to the power 2, 2 to the power 3, and then dot 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 up to 2 to the power k time. So here look at this. This loop is exited when? This loop is exited when the value of I is greater than or equal to n. When the value of I is greater than or equal to n, it is exited from the loop. Okay, we can say that when the value of I is greater than equal to n, it is exited from the loop. So I means what? I is represented by 2 to the power k. So we can say that 2 to the power k equal to n. Instead of I, if I write 2 to the power k, or we can write 2 to the power k equal to n. Now if I solve this one, the k equal to what? That is log 2 log n base 2. So what is the time complexity? Time complexity is log n. Sorry. Time complexity is O, or order of log n. It's very important. Next example. Look at this. The example 9. For I equal to 0, I less than n I plus plus, right? And then the next is what? That is j equal to 1, j less than n, j equal to j into 2. Some statements are there. So we know that this statement is executed how many time? N time. This statement is executed how many time? That is log n time. So what is the time complexity? Time complexity is O n log n. Clear? So these are the simple example of time complexity. In my next tutorial, we will find what? We will find the time complexities of linear search. Okay, and time complexities of binary search, but without using the recursion function. We know that if I use recursion function, then we have to depend on some recurrence relation that we'll explain in my some other tutorial. Thanks for watching.